Hello, this video is Measures of Spread, Part 4, and we're beginning with the kitten and the empirical rule example. The weights of adorable fluffy kittens are normally distributed with a mean of 3.6 pounds and a standard deviation of 0.4. What kitten weights bound 68% of the data? What kitten weights bound 95% of the data, and what kitten weights bound 99.7% of the data. So why don't you pause this video and see if you can answer those questions. Okay, so let's go ahead and draw out the normal curve. And what did it say was the mean weight was 3.6 with a standard deviation of 0.4, so 3.6 is in the middle. Okay, and then we are going to add one standard deviation above the mean, so plus 0.4, and you're going to get 4. And then we're going to add one more standard deviation, plus 0.4, and we get 4.4. And we're going to add one more standard deviation, so a third standard deviation, and we're going to get 4.8. If we go the other way, subtract one standard deviation from the mean, so 3.6 minus 0.4 would be 3.2. If we subtract a second standard deviation, we get 2.8. And if we subtract a third standard deviation, we get 2.4. So, using the empirical rule, one standard deviation each way would be 68% of the data. 2 standard deviations each way would be 95% of the data. I'll go up here. 3 standard deviations each way would be 99.7% of the data. So, what kitten weights bound the 68% of the data? It looks like 3.2 and 4. And then what kitten weights bound 95% of the data? 2.8 and 4.4. And lastly, 99.7, 2.4, and 4.8. So hopefully you got those. Okay. Why don't you pause the video and try this next example on retirement. I'll go ahead and read it for you. The mean retirement age is 64 with a standard deviation of 3.5. If the population is approximately symmetrical, answer the following questions. And it gives you boundaries, and you need to tell what percent that is. So why don't you go ahead and pause the video and try this one. All right, hopefully you worked through this one. So let's see how well you did. So I believe 64 is in the center, and we're doing a standard deviation of 3.5. So we're going to add 3.5. So 64 plus 3.5 is 67.5. Then we add one more, and we get 71. And we add a third one, and we get 74.5. Now we need to go the other way and subtract a standard deviation. So we're going to say 64 minus 3.5, and we get 60.5. And then subtract 3.5 again, and we get 57. And then subtract 3.5 one more time, and we get 53.5. So there's the boundaries. Here's 1 standard deviation, here's 2, here's 3. So if you want to go ahead and label those, this is 68% for 1, 68. This is 95. Oops, what happened to my 9? And then this is 99.7. Okay, so what percent of people retire between the ages of 57 and 71? So 57, 71, that's 2 standard deviations below, 2 above, that's your 95% right there. All right, what percent of people retire between 60.5 and 67.5? So 60.5 and 67.5 is 1 standard deviation each way, so that's 68%. And then finally, what percent of people retire between 53.5 and 74.5? Oops. 53.5, 74.5, that's 3 down, 3 up, which is 99.7% of the data. So hopefully you got that. All right, let's look at the next slide. Cheshevs Rule. So not all of our data can be symmetrical. I mean, it would be nice, but it's not a perfect world. It doesn't happen that way. So we use Cheshevs Rule for any data set. So whether it's symmetrical, whether it's skewed left, whether it's skewed right, we can use Chebyshev for all of them. Now, it is not as exact as the empirical rule. So even though you could use Chebyshev for symmetrical data, I would default to empirical if it is symmetrical, if it's bell-shaped, and I would just use Chebyshev for anything that's not bell-shaped. Now its rule, it was going to sound similar to the other one, just some different percentages. At least 75% of the data are within 2 standard deviations of the mean. So does it mean that it's approximately 75%? No, it means it's at least 75% or more of the data will be within 2 standard deviations of the mean. If you compare that to empirical, it was approximately 95% of the data is within 2 standard deviations of the mean. So at least 75% is 75 or more. It does include that if it were bell-shaped. So hopefully you see what I mean by this one is not as exact as empirical is. So this could be, it's basically giving you a range. It could be 75 or up. Now, the next characteristic or property is that at least 89% of the data are within 3 standard deviations of the mean. So this is so similar to what we were doing before. It's just instead of 95 for 2 and 99.7 for 3, we're at least 75 for 2 and at least 89% for 3. So you just have to learn 2 new percentages, but you work the problems the same way. You don't necessarily draw a curve, obviously, but everything else is the same. So here's an example. The mean for systolic blood pressure was 120 with a standard deviation of 10. The data is not symmetrical. Use Chebyshev's rule to describe the data. So basically you're going to end up with 2 statements. The first statement is going to say at least 75% of the data falls between and give those 2 boundaries, and then at least 89% of the data is going to fall between and give those 2 boundaries. So if we take the mean and we subtract 2 standard deviations, we start with 120 minus 2 times 10, 2 standard deviations, that's 20. 2 tens would be 20, and you get 100. If you add, you get 140. So at least, and then there's 3 right here. If you subtract 3 tens, if you add 3 tens, you get 90 and 150. So we can conclude that at least 75% of the people had systolic blood pressures between 100 and 140, and at least 89% of the people had systolic blood pressures between 90 and 150. Okay, so pause the video and try this one. Okay, so the mean score on a statistics test is 80 with a standard deviation of 10. Hopefully you worked this one out. You paused the video and worked it. So let's see what the answer would be. So 75, at least 75% of the data, that's 2 standard deviations above and 2 standard deviations below. So I'm going to start with the mean, which is 80, and I'm going to subtract 2 standard deviations. The standard deviation is 10. So I'm going to say 80 minus 20, and I'm going to get 60. And then that's 2 below, so now I'm going to go 2 above. So 80 plus 2 standard deviations. Standard deviation is 10, so that's 80 plus 20, and I get the boundary 100. So at least 75% of the data fall between 60 and 100. Then it says between which two scores must at least 89% of the data fall. So 89% of the data is 3 standard deviations. So I'm going to start with the mean of 80, and I'm going to subtract 3 tens. And that would be 80 minus 30, which would be 50. And then I'm going to add 3 tens. So 80 plus 3 tens is 80 plus 30, and we get 110. So at least 89% of the data is between 50 and 110. And so that's the last slide for measures of spread. If you have any questions, as always, please let me know.